Today's lesson is on theoretical probability, and so by the end of the lesson you're going to be able to determine the theoretical probability of an event. When we think about theoretical probability, it is the possible outcome that's going to occur. It's actually, there's no experimenting going on. You're just thinking about your total number of options versus what you want to occur. And that what you want to occur has to do with our favorable outcome. Okay? So what is the theoretical probability that you can choose the correct shell with the ball underneath? So there's supposed to be one ball underneath one of these shells. Okay? And our favorable outcome is going to be the shell that actually has the ball underneath. So what is the ratio of our probability? It's the number of favorable outcomes over the total number of outcomes. And then we think about how many favorable outcomes are there in the shell game. If there is one shell with a ball underneath, that is our favorable outcome. And then how many total outcomes are there in the game? I could pick up this shell, or this shell. So I could pick up 3 different shells. So if I think about what the probability as a fraction, it is 1/3, or 1 out of 3. If I go ahead and change that to a decimal by dividing 1 divided by 3, I get an answer of 0.3333, and it keeps repeating. If I turn that into a percentage by multiplying it by 100, I get a 33.3 repeating decimal, so 33% about. Okay. So we're going to go ahead and add a few more shells. Now we have 6, and now we're actually going to have 3 balls on there. So there is 3 balls underneath these 6 shells. So we think about how many favorable outcomes are there in the shell game. We have, see now there's 3 balls, there's 3 favorable outcomes. And then how many total outcomes are there in the game? There's 6. So what is the probability as a fraction? There is 3 out of 6. If we change that to a decimal, it turns out to be 0.5. And if we turn it to a percent, by multiplying it by 100, it is 50%. So another example you're going to go ahead and look at is our cards, picking a card. So what is the theoretical probability that you can pick a red card? So if we think about a standard deck of cards, there is 52 cards in it. Okay. Out of those 52 cards, we have a numbers 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, King, Ace. There is 13 cards per suit. Okay. And our suits are our hearts, clubs, spades, and diamonds. Okay, and there's 13 of each of those. That gives me my total of 52 cards. So if I think about how many cards are in a standard deck, let's answer that as 52. How many red cards are in a standard deck? I have my hearts and I have my diamonds. That gives me 26. And I think about how many cards are in a standard deck. That is 52. And so what is the probability as a fraction? I have 26 over 52. If I turn that into a decimal, 26 divided by 52, I get an answer of 0.5. And if I turn it to a percent by multiplying by 100, I get 50%. So I have a 50% chance of picking a red card. So if I think about what about a black card, we have how many black cards are in a standard deck. Again, there's my clubs and my spades are my black cards, so I have 26 of them. There's 52 cards. And what is the probability as a fraction? Again, it's 26 out of the 52. If I divide those, my decimal is a 0.5, and my percent is a 50%. So how many cards, so now if I look at a spade, how many cards with a spade suit are in a standard deck? I have, let's move this up for you. I actually have 13. Okay. Alright, and then if I think about how many cards are in my standard deck, I have 52. And what is the probability as a fraction that I'm going to pull a spade? 13 out of the 52 total. If I turn this into a decimal by dividing, I get 0.25. and then I also get a 25%. What is the probability change if you were asked for a diamond card? Explain our answer. There really is no change in this probability because there's an equal number of diamonds to spades as well as the other suits. So we'd say no change there on an equal number of diamonds, spades, hearts, and clubs. Okay. So now my next question asks me, what about a heart or a face card? Okay. So now we have two portions here. We have a heart, and that or word means I could also get a face card. It's either or. So if I think about how many hearts or face cards are in our standard deck, I have 13 hearts. Okay. I'm going to add how many face cards I have to it as well. Now, because I'm looking at all my hearts, the face cards, which is my, let's go ahead and clarify this. My face cards are my jack, my queen, my king. Okay, those are my face cards. So if I think about how many face cards I have in the deck, I have 3 face cards for hearts, 3 for spades, 3 for diamonds, and 3 for clubs. But I've already thought about my heart ones, so I can't add those in as well. So now the face cards that I add in have to be the ones that are my spades, clubs, and diamonds, and those are 9 of them. Okay, and that is going to equal 22 total. So how many cards in a standard deck? Again, that's 52. What is the probability as a fraction? It is 22 over 52. And if I'd like to simplify that, I can to 11 over 26. Okay. And then I need to go ahead and divide 11 by 26 to go ahead and get my decimal. Plug that in the calculator. And I get an answer of 0.423. And I'm just going to round it there to the nearest thousandths. And I turn that into a percent by multiplying by 100, and I get a 42.3% chance. Alright, so it's your turn to go ahead and pause the video. I'd like you to go ahead and try our 4 problems here about rolling the dice, choosing a vegetable, gumballs, and then boys and girls in the classroom. Once you've solved those problems on your own, you may go ahead and start the video back up, and we'll talk about your answers. So the first one for you is, and you had to make sure too you write it in a fraction, decimal, and percent form. First one was rolling a 6-sided die and having it land on a 4. So if we look at our options, there's 6 options, and 4 is there's 1 option to actually do it. So I have 1 out of 6, which in decimal form is 0.166666. Keeps going on forever to get me a percentage of 16.6%. Next question was choosing the vegetable corn or carrots from the choices potato, carrots, green beans, or corn. I notice that I can do 2 favorable options out of 4 total, giving me a 0.5 as my decimal and 50%. Next one was getting a red gumball from a box of 3 green, 4 blue, 7 white, and 7 red gumballs. And so my favorable outcome is my 7 red. If I total up all my gumballs, I get 21, so 7 over 21. And that actually simplifies to a third, giving me a 0.333333. Turn it into a percentage, and we get 33.3%, and the 3 is repeating. And then lastly, choosing a boy from a class of 24 students with 18 girls. Because there's 18 girls, I know that there would be 6 boys to make up my 24 students. So I need to go ahead and say that it is 6 over 24, simplifying to 1/4, which is 0.25 and equals 25%.